Hello, I'm Bruce. I'm the author of Stardust, a StarCraft Brood War bot. And about 2 years ago, I fell into a rabbit hole of optimizing the mineral mining of my bot. So this video is kind of sharing some of the findings that I've made along the way, so that they can hopefully help some of the other bot authors use some of these techniques if they're interested in optimizing their mining. So getting started, this is kind of the normal case when you're having a worker mine some minerals, and I'll look at these things in a replay in more detail in a minute, but I mean, you order the worker to mine, it goes to the mineral patch, it has a couple of frames transitioning to mining, then the mining timer starts counting down, at some point it's finished and the worker gets the minerals, and it goes back to the depot, delivers the minerals, and then everything starts over again. However, there is one thing that adds some delay to pretty much all of these transitions, and that's the order process timer. So the order process timer is something that affects all units in Brood War. It generally runs on a 9-frame cycle where it has a value between 0 and 8 inclusive that gets decremented every frame, and then when it goes below 0, it gets reset to 8. And the effect of this timer is that all of the unit's orders don't get processed unless it has a value of 0. So it's kind of a way for the developers of the game to save on CPU by having a whole bunch of orders only get processed every 9 frames instead of having to process them every frame, right? And the way this is actually implemented in the game is pretty simple. There's an order process timer. It gets decremented as long as it's non-zero, and if it's 0, it gets reset to 8, right? So you can kind of see that it falls through this if it's 0, and then it processes all of these orders that are kind of beholden to the order process timer value, right? And there are some orders that are executed before that because they're, for whatever reason, important to run every frame. But the vast majority of the orders are below this filter, right? So they're and this includes all of the interesting orders for mining minerals. So if we look at the how this would actually look in the game, this is CherryViz, which is based on the OpenBW replay viewer, something that was built by the Facebook team when they were working on StarCraft Brood War AI. And I've made a few kind of extensions to it so that if I select the unit and look at the details, there are some additional values here than you would see in the standard CherryViz. So the interesting thing that we're going to be looking at a lot here is this timer value. This is the order process timer. And we also have the main timer here, which is the main order timer, which we will see has some, it's used when the unit is actually mining. So for this demonstration, I've just ordered it to mine from a patch, and then we can kind of see what it does, right? So so the order was issued on frame 1, and we see the worker starts moving towards the mineral patch. At some point, it arrives at the mineral patch, and we can kind of, if we look at this, you can see it has actually arrived at this point, but the order process timer is at this point 6, so it has to wait until it actually reaches 0. So here at the end of this frame 56, it's at 0. So the next time it goes through the order process timer check, it will be 0 and will allow it to process orders. And here we see on the next frame, it transitions to wait for minerals, then to mining minerals. And on the first frame of mining minerals, it's actually not mining yet because the main timer hasn't been set. But then the next frame, it gets set to 75, and then we start decrementing, right? But we just go through every 10 frames. So in mining minerals, on the frame where the main order timer has reached 0, it will get the minerals and start going back towards the depot. But of course, we're still beholden to the order process timer, so we actually also have to wait until the order process timer has reached 0. And now the unit is able to transition to reset harvest collision, where it basically paths towards the depot, and then it starts return minerals, and we go return minerals, And the same thing happens here, where you can see we arrive at the depot on this frame, and for this one we had to wait one extra frame because we hit zero at the end of the frame after we've arrived, right? So we will, in this case we only had to wait one frame, then we return the minerals, and then it starts pathing towards the mineral patch again. Digging a bit deeper into the order process timer, there's also a functionality in the engine that every 150 frames, starting on frame 8 for whatever reason, all of the units get their order process timers reset to a value in the range 0 to 7 inclusive. I have no idea why it's 0 to 7 and not 0 to 8, but I mean, it might just have been a bug. The reason for this to happen, I assume, is to kind of spread out the values of the order process timer. And given that the order process timer was almost certainly added to help reduce the CPU needs of the game, obviously, if all of the units end up bunching up on specific order process timer values, then the CPU would still spike on some of the frames. So I think they added this so that, you know, every few seconds it rebalances all of the order process timers in order to allow the CPU to be kind of relatively constant across all of the different frames, right? And this, of course, has a lot of impacts on mineral mining, since we've already seen that the order process timer has an impact on most of the timings. So whenever this resets and you kind of get an unpredictable value on the order process timer for all of the workers that are mining, then of course that makes it difficult to predict exactly where all of these transitions are going to end up, right? So let's take a look at how this actually works in the game. So here we have another replay where we're looking at the same thing, where the worker gets ordered to mine minerals from a patch, but I've deferred the mining order until frame 125 so that we can see the effect of an order process timer reset. So here we can see the order process timer reset will happen at frame 158, since it's after frame 8 and then 150 frames. And we can see here, if we look at the timer value, it was 8 at the end of frame 157, and then at the end of frame 158, it's 3. So this unit's order process timer got reset to 4 at the start of frame 158. Then it ran through the normal cycle to decrement it, and it ended up on 3 at the end of the frame. And the way the resets are implemented in the game is also fairly simple. There's this, you know, order timer counter that's a global counter that starts at 150 and decrements every frame, and when it hits 0, then it gets reset to 150, and all of the visible units have their order process timer set. And we can see that this actually isn't using any RNG to set the order process timers. It's just taking them one at a time, and every unit gets a value 1 greater than the previous one until it hits 8, and then it gets reset to 0, right? So it just ends up taking all the units in the list and applying 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, so on and so on. We can also look at some of the impacts of order process timer resets during some of these different transitions, right? So here I've, you know, modified the frame that we issue the command so that we can see different impacts of order process timer resets. So if we look here at the reset, I've timed it so that the reset will happen exactly when the worker is transitioning into the wait for minerals order. So it's just transitioned into wait for minerals. Normally it would transition to mining minerals on the next frame, but now we get a reset. And that means that it actually skips processing the order that would transition it. So the worker ends up getting stuck in wait for minerals for an extra 4 frames, since that was the value that this worker got its order process timer reset to. Similarly, we can look at the reset happening on the frame when the worker transitions to mining minerals. So this is this first frame where the actual mineral mining timer hasn't started decrementing yet, but the order has been set to mining minerals. But here again, since the reset happens, the worker doesn't actually complete the transition to mining minerals where the mining timer is actually decrementing. So there's an extra 4 frames of delay, and then the mining actually starts decrementing, right? So here again, there's also 4 frames of extra delay in transitioning to mining, even though the order looks a bit different, right? It still doesn't actually count as mining since the mining timer isn't actually decrementing. And we can also look at delivery. For this one, I've had to put it a little bit further into the future because the worker couldn't get back for the first order process timer reset. So here we're looking at the next one that happens at frame 308. So here the worker is returning minerals. It actually returns the minerals on the same frame as it's about to have an order process timer reset. And here we can see that the reset happens on the first frame where it's on move to minerals, and that actually causes it to not start pathing towards the depot until the order process timer reaches 0 again, and then it can start doing its pathing. So you can kind of see that with the order process timer resets, there are these kind of extra delays that can pop up in different places. Okay, so how can we actually influence the order process timer? When we are moving towards the mineral patch, what we can do is we can reissue a move to minerals command. What happens when we do that is there's a frame where the command is kind of taking effect and the worker starts replanning the path towards the patch. Then on the next frame that gets finished and the order process timer cycle restarts. So here we can kind of impact or give the worker an order process timer value that we know, right? So if it's moving towards the patch and we don't know what value it has, or we know it has a value that's going to cause some delay of starting to mine, then we can reissue the command, and then we know what the order process timer value is going to be at a certain frame. Of course, unless there's a reset in between when we send it and when it reaches the patch, in which case there's not that much we can do. Some limitations to this are that we can't send 2 gather commands exactly latency frames between each other. It just gets rejected by the Brood War API. And we should also avoid having an order process timer reset take effect exactly as the path is being replanned. All right, so if we look here at how a gather command can be reset, here we have our probe, and on frame 1 we send a gather command, and on frame 20 we resend the gather command. So we can say here after the initial gather command, the worker is moving towards the patch. Frame 20 is the frame where we actually issue the command, but there's latency frames, so the command will actually only be executed at the start of frame 24. And here we will see the order process timer reset to 0. The state, which is like a state flag for the order that the worker is currently in, gets reset to kind of indicate that the engine is doing something right. It's repathing in this case, right? Frame 25, the state goes to 1, the unit is finished repathing, and the timer goes to 8. So here it's starting to cycle down again, right? So here we, have resent, and now we know what the order process timer is. And if you do this in kind of an intelligent way, then you can make it so that when the worker arrives at the patch, it has an order process timer value that will allow it to start mining immediately or with a very short delay. So I mentioned that one of the limitations was that you want to avoid having an order process timer reset frame on the kind of in between the 2 pathing steps in the gather command. So to demonstrate this, I've kind of set it up so I'm issuing a move command on the first frame. and then issuing a gather command that then takes effect where a reset happens in between the pathing. So here there's some latency, and the worker is starting to move based on the move command I sent. And we can see here on frame 8, where there's the order process timer reset, the order goes to a weird one called harvest 1, which is kind of indicating that it's in some in-between state, right? And you can see while the order process timer is going back to 0, the worker just keeps moving along the path that was from the move command. And then finally, once it's hit 0 again, now it's able to complete the processing of the gather command, and then it starts pathing towards the patch, right? So you will definitely get unexpected paths if you have an order process timer reset when the gather command is basically in between its repathing state. For return, it's very similar. You can, of course, reissue the return cargo command when the worker is on its way back to the depot. However, there is a different behavior in that the worker will actually stop while it's repathing. And it appears to be because of a bug in the engine that it detects a collision of the unit with itself, which is not happening on gather because there's like specific exclusions for workers that are in gather commands or gather orders. But that isn't there for return cargo, so when you issue return cargo, the unit will actually stop for a couple of frames while it repaths. Okay, so let's take a look at what the impact of a return cargo command is. So here the worker is pathing back towards the depot. We issue the return cargo command on frame 152. That then takes effect fully on frame 156. Here we can see the order process timer resets, and the transition for resending a return cargo is a bit different than gather. That doesn't have this split between 2 frames, so it just goes immediately up to 8, which indicates that it was 0 at the start of the frame, right? However, we can see that if we advance a couple of frames here, the worker is frozen, right? So this is this impact of the collision being detected in the engine, which causes it to not move for a couple of frames, and then it continues along its new path. So, I mean, the advantage of this is, of course, that we still get a known order process timer value. So we can still time things to hopefully have the delivery happen earlier, even though we have this 2-frame delay while it's repathing. And the other thing is that we do still get a new path, so it can still be used for straightening paths or getting on faster paths, right? All right. The next thing I'd like to talk about is subpixel positions. And this is something that is not visible to either players of the game or to bots through the BroodWar API. It doesn't reveal what the subpixel positions of any units are. But in the game engine, all of the movement is calculated on subpixels. And the reason for doing that, and is the same as it is in I think most games, that you want to be able to do smooth pathing even if a unit has a speed that is not an integer multiple of pixels. And in order to do that properly, you kind of need to track it in subpixels, right? So why do we care about this for mining? There are basically 2 things. The subpixels will kind of decide which pixel positions you end up on during a path. So you might have a situation where everything looks like it's pathing the same as something you've seen before, and you resend a gather command because you think that the worker is going to arrive on a path that you know. But you may suddenly see that the path deviates, like the worker moves an extra pixel or 1 pixel less than you were expecting. And that's just because the subpixel position is different than it was the first time you observed the path, right? So you kind of have to consider that there's some unpredictability in pathing based on the fact that the subpixels can be basically anything, right? And the other thing is that it can result in collisions with the patch or with the depot. And we'll dive a little bit deeper into this, The reason for this is how the units actually move in subpixel land, right? So if a worker is pointed at a patch or pointed at a depot and it wants to go in the opposite direction, it can't actually just spin on its center. It has some forward motion while it's turning. So the result of this is that if the subpixel position was close enough to the patch of the depot, this forward motion will cause it to run into the patch of the depot, and that triggers collision resolution. And the collision resolution for these kinds of collisions does require an extra order process timer cycle. So it does add a significant time delay. So we can look here at a collision with the patch. How does this actually reveal itself? And what we can do here is we can look at the end of mining here. So we go into reset harvest collision, go to return minerals. You would expect the worker to start turning and moving towards the depot, but nothing happens for an entire order process timer cycle. And then once it's finished, the pathing is done to resolve the collision, and then the worker starts moving. So you don't really see it exposed in any orders or anything, but you see it as the unit just not doing anything for an entire order process timer cycle, right? And it works in the same way with the collision on the depot. So here I have the worker go into a different patch so that it will actually collide when it returns. And we'll just go forward here. So again, we have delivered the minerals, and normally you would expect the worker to immediately start repathing towards the mineral patch. But again, here we see the worker actually turned a little bit, so here it didn't collide on the very first frame, but maybe the second or the third frame. But then once the collision happens, it has to wait until its order process timer cycle completes, and then it will start moving again. Another detail on returning minerals is that if the worker returns its minerals on the exact same frame as it arrives at the depot, so basically you arrive at the depot on the frame where your order process timer is 0, then it will not lose its speed, or not lose all of its speed. It will have already been decelerating a bit, but it won't actually stop completely. And this is a main difference between returning and mining minerals, because obviously with mining minerals, the worker has to stop to do the mining. But on return, it has this other behavior where it can actually carry speed through the return. Now, this can be a good or a bad thing. It can be a bad thing if the worker is delivering to the middle of a depot, and that's because of the collision we just talked about. With the added speed that the worker has, it makes a collision almost certain. You can imagine that, where if the worker is stopped, it requires subpixel values that are pretty close to the depot in order to cause a collision. If it's maintaining its speed, then it's just going to crash into the depot no matter what, right? However, if the worker is delivering on a corner of the depot, then it can, depending on the orientation of everything, actually kind of continue past the depot and then turn, and it kind of gives this nice effect where it looks like the worker is being slingshotted back towards the patch. So looking at this effect, and again, I've kind of set up some commands so that we get on a path that allows this. So we can see here that the worker arrives at the depot on the exact same frame as its order process timer is 0. And that allows it to maintain its speed. So its speed stays at, in this case, over 60%. And it's able to turn to avoid crashing into the depot. And then it goes on its way, right? And when you see it playing in real time, it looks really fast, right? Compared to the worker stopping and then having to accelerate up again. And workers are not the fastest accelerators in the game. So certainly if you can plan paths to get this behavior, it's a good thing. But if you know that the worker is going to be delivering to the middle of the depot, then you probably actually want to optimize for the auto process timer to be 1 at the frame where you reach the depot. So that will actually wait an extra frame, but avoid the collision that incurs a 9-frame auto process cycle delay. So far, we've only been looking at one worker, but of course, when your base starts getting saturated, you will have 2 workers assigned to all of the patches. So here we have some other timing issues that come into the picture. In the move to minerals order processing, as soon as the worker reaches a distance of 10 or less from the patch, it will check if the patch is available or not. And if the patch isn't available, then it'll try to find a different patch. It'll search within 8 tile radius. And if it finds another patch, it will switch to it. If it doesn't find another patch, then it doesn't try to do this again. So it kind of sets a different state and essentially becomes locked to the patch that it's currently targeting. And of course, through all of this, the order process timer still applies, right? So if the order process timer is not 0, then the move to minerals order is not getting processed, so it's not going to check for any patch occupation or whether it's a switch and all of this stuff, right? But if we look at how a patch switch looks, so here I'm sending 2 of the workers to mine the same patch. The first worker is mining, the second worker is moving towards the minerals, and it's still moving towards the one that we targeted. And here, it's not within 10 distance yet. Now it's probably within 10 distance. The order process timer isn't 0 yet. Now the order process timer is 0. It's going to process its move to minerals order on the next frame. And here we see that it changes the target of the move to minerals to a different patch. And then it'll go over there, right? So this is obviously behavior we don't want, because we want to have our workers taking over from each other fairly consistently on the same patch, right? So how do we want to do this? If we are thinking of kind of normal transition where one of the worker mining completes mining and then the other worker starts mining, then the key frame is the one where the mining worker goes to this reset harvest collision order. It's the same frame where the worker gains the minerals, and you can see it start carrying the minerals. As soon as that order is processed on the worker that is finishing mining, then another worker will be able to start mining from the patch. So the patch will be marked as available when the mining worker is finished with that. However, whether the other worker can take over on the same frame or not depends on which order the workers are processed in. So in the game loop, it will just loop through every unit one at a time and process its orders. So if the mining worker is first in that list compared to the other one, then it will process the order, the patch will be marked as free, and when the next unit, the unit taking over, gets its orders processed, then it will actually be able to transition directly into wait for minerals. However, if they're in the opposite order, then that isn't the case. So if the worker taking over has its orders processed first, the patch will still be occupied when it processes its order, and it would then try to switch patches. So what we want to do is keep track of where our units are relative to each other in this list. And luckily that's fairly simple, because the list has the units added to it in the order that they have become visible. So the units that have their orders processed first are the units that have most recently become visible in the game. And what we mean by visible is obviously when the worker spawns from the depot, or I'm actually not entirely sure with Zerg with the morphing. It might be when the larva was made visible. or whenever the unit came out of a refinery or was dropped by a dropship, like basically anything that takes the state of the unit from being hidden to being visible causes it to be inserted into this list, and it will have its orders processed before units that were made visible earlier in the game. Right? And then we can say, okay, what about this case with the patch locking where it tried to switch patches, but it actually couldn't find another patch that was available? Well, this is a very interesting uh, case, because what happens there is that the worker taking over basically doesn't do anything else in terms of orders. It gets added to a queue of workers that are waiting to mine from the patch. So this is something that's stored on the patch unit in the game engine. And when the mining worker is finished, it looks at the, like as it's marking the patch as now free to be mined, it checks the queue on the patch. And if that queue has any units in it, then it directly transitions that unit to mining minerals. So this is a really nice thing for optimization, as we don't have to worry about the order process timer of the worker taking over or the relative positions of the workers in the list of units, as the worker taking over doesn't even process its orders. It gets its orders processed by the unit that is finishing. So if you want to see this in action, for this test, I've just simulated the worker not being able to find another patch by killing all of the other patches. So that's kind of a shortcut for doing this. So here we can see it's the exact same orders as before. The unit is approaching, it gets to 10 distance here. But of course here it's not able to find another patch, so it doesn't do a patch switch. And we can actually see the state of the order has changed. So the engine has marked, okay, I tried to find a different patch, but I couldn't, so now I'm in a different state. When the worker is at the patch, so now the distance is 0 and the order process timer is 0, it transitions to wait for minerals. And it also stays in wait for minerals with this state, with this other state, right? And this is again the engine signaling that this unit is waiting for minerals and is locked to this patch and should not try to switch to a different one, right? If we then look at the worker that is mining, and we just go forward until it's actually about to be finished. So here the main mining timer is 0, and now the order process timer is 0. So on this next frame, it transitions to reset harvest collision, and the worker taking over is transitioned to mining minerals. So it's a very quick handoff in this case. All right, so putting everything together, if we want our bot to mine as efficiently as possible, what do we want to do? We want to make sure we optimize the order process timers so that whenever we arrive at the patch or the depot, we have our orders processed as early as possible. We want to try to mitigate the impact of these order process timer resets, and that is very much about knowing when they're going to happen and maybe trying to avoid some of the unfortunate transitions. In some cases, you may reissue commands at a different time than you usually would because you know a reset is going to happen, and you can kind of play the numbers and say, okay, if I get a random order process timer value between 0 and 7 inclusive, maybe it's better for me to resend when the order process timer reset happens so that I get a known value, right? We can try to track paths and resend at positions that give shorter paths. And also an important thing here is fewer collisions. So there are definitely some paths where the normal pathing will give collisions basically every time. But if you do some intelligent resends, then you can maybe avoid it by having the workers' subpixels align a bit better. And when you're doing takeover from another worker, it's important to try to use this patch locking behavior as much as possible, since it really makes a more efficient takeover. A couple of extra notes. One thing is around these order process timer resets and whether the values are actually predictable. And as I mentioned before, it's not actually using RNG. So so you can say, okay, well, if I know the order of the units in the visible units list, then I know what values they're going to get, right? And this is true. However, the visible units list doesn't only contain your own units. It includes all of the units in the game. So all neutral units, all enemy units that are also in that list. So that means that it can be tricky to predict, right? Of course, you can probably do some kind of tracking, like saying, okay, I know that my two units here, last time there was a reset, one of them got a value that was 3 higher than the other one, right? Something like that, right? And probably the distance between them is the same as it was the last time there was a reset. So, I mean, there's probably some logic that could be applied there in order to do some prediction, but it's not something that I've looked into very much in detail, since I kind of considered it to be a bit too far into the micro optimization category. And this is, coming from somebody who spent 2.5 years optimizing mineral mining. The exception to this is at the very start of the game, because here you actually do know not necessarily exactly what the position of all the workers in the visible unit list is, but you know there's a relatively small number of different options. The things that can affect the order of the workers at the start of the game are the relative positions of the start positions. So the game will add all of the units for the start positions in a certain order. So if your start position is ahead of your enemies, then you know where you are on the unit list compared to them. And also whether or not the opponent is Zerg, because Zerg has more units at the start of the game than the two other races do. So in Stardust, I've used this for planning the initial worker split, basically saying that, okay, if I know my opponent's race, and in some cases, if it's a 2-player map, you also know your opponent's starting position, right? Even on 3 and 4-player maps, you know if you're in the first or the last start position, that your units are in a certain place in the unit list, right? So I kind of say, okay, I know the possible values that the order process timers are going to get reset to for each of the units, and then I can plan the initial paths fairly accurately, right? And the last thing I'll talk about is, well, what about gas mining, right? And here there is a very different case in terms of all of the actual gas collection logic, where it's not governed by the order process timer. And this kind of makes sense because gas collection is limited in that you can only have one in the geyser at a time, and you usually only have one per base. So if you had this case where they were randomly coming up to 9-frame delays in getting a new worker into the refinery, it would really add too much variance to the collection, right? So the game checks for gas mining every frame, and that's both for workers waiting to go into the refinery and workers that are in the refinery that are mining gas, right? So the only thing you can actually impact here is the pathing and the delivery at the depot. So you could make that a bit faster, but I haven't looked into it, since my assumption is basically that you'll still need 3 workers. I don't think there's any way you can increase the speed enough to get down to only needing 2 workers on normal geysers. Probably for geysers that are placed below the depot, you can get full saturation with 3 workers instead of 4. And of course, if your bot is pulling workers from gas, so you only have 1 or 2 workers mining at a time, then you could of course get a faster income if you are saving some frames on the delivery of gas every time, since the worker will be arriving at the refinery again, where there isn't anybody they have to wait for. So maybe this is something I'll look into in the future. An advantage of gas pathing is that whenever a unit is made visible, it always has the same subpixel value of 00. So anytime a unit pops out of a refinery, you would know the subpixel positions, which would actually make pathing a lot easier. But I mean, on the other hand, there isn't really much of a benefit to gain here.